When we bought this State College home in 2012, it had been fairly abused, with paint on the walls, cat urine in the corner, and no closet doors. I had two plans: replace the garage with a first floor apartment, and make the house as energy efficient as possible. We started with the basics: cleaning up, stripping, and repainting. But the first step to a zero-emissions home is stopping the heat loss. We insulated the attic, fixed the storm windows, and sprayed isonine insulation around the sill plate at the top of the foundation wall. An old house leaks a lot of air, and isonine both keeps heat and heated air inside. We also plugged the unused fireplace. In 2015, we were ready for the next step: putting on solar panels. Working with local solar installer, Sun Directed, we designed an 8.32 kilowatt system that covered most of the available roof space. Over the last 5 years, this system has produced about 9 megawatt hours of electricity per year, covering about 2/3 of the consumption of the 2 units in this house. 9 megawatt hours is less than the average household consumption in the US, so I knew it would not cover all of the 2 units' use. I also wanted to get off natural gas, and I considered geothermal, but the upfront costs were just too great. So in 2019, I installed this high-efficiency air-to-air heat pump. But that also rose the electricity consumption for this household. In 2019, we then put in new thermopane windows and front door and began laying plans for a solar carport. This freestanding carport was designed by engineer Joe Lichty with steel manufactured by EAB Ironworks in Bellefonte. It was not cheap, but I figure I saved about 20 grand by not installing the geothermal unit. And it was the only way to add more solar panels. Once again, I turned to Sun Directed, and they also served as general contractor of the project. It even comes with a charging station to plug in electric vehicles. And that makes us very close to a carbon neutral home.